This video describes a method for generating and using a polymer microarray using an on-chip photopolymerization technique. First, glass slides are dip-coated in polyhydroxyethyl methacrylate, or FEMA, to produce a low-attachment substrate. Monomers are mixed at varied ratios to produce a library of monomer solutions. The solutions are transferred to a glass slide format using a robotic printing device and cured with UV irradiation. The monomer polymerizes and the solvent is vacuum extracted. Following high-throughput surface characterization, the microarrays can be used for screening for materials performance, such as bacterial attachment assays. Analysis of attachment data is a step towards the discovery of novel biomaterials, highlighting the utility of the polymer microarray format.
The main advantage of this technique over existing methods where the biological response of different materials are investigated one material at a time is the parallel screening of hundreds of materials which are easily manipulated on a single slide. This technique can easily be adapted to various biological assays such as screening for materials that resist bacterial attachment or support the expansion of stem cells. This technique has helped discover materials with potential applications for supporting pluripotent stem cell expansion for regenerative medicine. We are also very excited about the recent discovery of materials which resist bacterial attachment with potential to reduce the occurrence of medical device-associated infections.
Generally, users new to the method will struggle to optimize the conditions required to print a microarray because it is difficult to predict the optimal conditions. Getting even small details wrong can lead to non-usable arrays.
It is also essential to consider which bacterial strain and cultural condition will be used, because attachment and biofilm morphology are specific.